So in this part we are going to learn how to present this theorem and to prove the theorem. Okay, so what is given? So first, like I told you already when I was explaining the first video, what was given is a right angled triangle, right angled at A. Okay, so we'll say given a right angled triangle. Okay, what is our name of the triangle? ABC. So a right angle triangle ABC, right angle at A. Okay, so this is what we have written, right angled at A, and now what is there? And from A what we have drawn is we have drawn a perpendicular. Okay, from A, AD is perpendicular to BC or hypotenuse. Okay, so this much information is what we know from the theorem itself. Only after that it tells you, okay, these two triangles are formed and they are similar to each other and all that. Okay, and there is no construction. Please note, this is not construction, it is a part of the theorem, because the theorem tells you to draw the perpendicular. Okay, then we come to what we need to prove. Okay, so you see your proof, to prove is in three parts. One, because the theorem told you to do that, I'll just explain this part to you. First, the theorem told you that if you draw a perpendicular, then the new triangles so formed, both the triangles are similar to the original one. Means the original triangle was ABC. So it tells you that you have to prove triangle ABC is similar to triangle ADC. That is your first one, ADC. Again it tells you triangle ABC, okay, similar to triangle ADB, and the theorem tells you they are similar to each other, means these two are also similar to each other. So this is the third thing that you have to prove, triangle ADC is similar to triangle ADB. Okay, so ABC was our original, so the theorem tells you, okay, the new triangles so formed, these two are similar to the original, so this was the original, are similar. Okay, and they are similar to each other, so they have to be also similar to each other. So this is what is there in the theorem to prove. Okay, and you are going to start the proof. Okay, and I want to see everybody solve this theorem yourself, because we have done similarity. I will help you with the first one. Okay, so you start with in triangle ABC and triangle ADC. So these are the two triangles that we are considering. So you can see ABC, okay, and ADC. Now one thing very important when we prove similarity is we know two things in similarity, that we need proportional sides and we need angles. Okay, so from the information that is given to you in the question, okay, what we only know is angles, right angle. Okay, we do not know anything about side. So think it straight away that you have to use angles. Okay, based on the information that is given to you in the question, that you have to use angles to prove this two triangles are similar to each other. So in this we start with the first one, is a right angle. Okay, that is known to everybody from the beginning of the question, from the diagram. A or BAC is 90 degree, we know, and in this small triangle we also know ADC is also 90 degree. Okay, so for the large triangle we say angle BAC is equal to angle ADC. Both are 90 degrees. Both are 90 degrees. Okay, so the second thing that you'll find is an angle that is common, because it is made inside this triangle only. So you can see, if we are talking about the large triangle, then the angle that I am talking about is this. For the larger triangle, that is called BCA or ACB. For the smaller triangle, the same angle will be called ACD. Okay, and that is common to both the triangles. So you'll see angle ACB for the large triangle, and the same angle is ACD for the smaller triangle. And what do we call them? Common angle. So means it's common to both the triangle. So we can say therefore triangle ABC is similar to triangle ADC. Okay, and reason being angle, these are called the axioms, okay, of similarity. Okay, we are considering this as equation number 1. I want you to prove this second one. So once the second one is proved, for the third one you need not prove similarity. I'll tell you what you have to do. If this is proved and this is proved, this I have just proved, and you have to prove this. Okay, once these are proved, then you see this triangle is similar to this triangle is also similar to this. Hence we can say from equation 1 and from equation 2 straight away this will be similar to this. So in the last one you only have to write this statement, and you have to write from equation 1 and 2. Or you can say both triangles are similar to triangle ABC. So this is true. Okay, and you'll finish this theorem and write hence proved. Okay, and you'll send me the final solution.